Okay, see Lindelof videos, sketch an exponential function. We talked about growth functions in the last video, so in this one I want to talk about decay. First thing I want to talk about is the fact that the general form of this thing is a times b to the power of x. And we can draw some really good conclusions about this just by being able to define or say what values b can take. B must be greater than 0. B cannot equal 1, which leaves us a lot of room because we talked about in the last video, well, what happens if b is greater than 1? Well, if b is greater than 1, we get a growth function that looks like that. But the other possibility is this, and that's the one we're going to talk about today. The other possibility is that we have b is greater than 0 because it has to be, but less than 1. That makes it a fraction, a proper fraction, right? Like 1/2 or whatever. So these are fractions. Well, if that happens, we get something called a decay function. And it looks like this. Let this be the Cartesian plane. And a decay function does this. It starts really high out here somewhere, and it comes down like this, and it just goes towards 0. It never actually gets there, but it looks like this. And what's really interesting about this is that I can predict, by looking at this function, I know that b has got to be a real fraction, a proper fraction. Or by knowing that b is a proper fraction, I can tell you it's going to do this. Either way, I got really important information. So let's try to graph a couple really quickly. Let's try this one. We have y is equal to 4 times 1/2 to the x power. So let's be careful. This is a, which is our initial value, which we don't need to know about right this second. But we have b is equal to 1/2. So that's the first thing I'm going to say to my professor, that I know that b is equal to 1/2. And then I'm going to make this comparison. I'm going to say 1/2 compared to 1. 1/2 is less than 1, but it's also greater than 0, isn't it? So it fits in this mold right here, doesn't it? So what I can tell just from that piece of information, as I start to sketch my graph before I put in any numbers, I know it's going to take this general shape, right? It's going to, this thing is heading towards 0, but it's never going to get there. So from there, this is a good start. This is the general slope. So you're saying, well, how do I know how much it's bent one way or the other? You kind of don't know the severity of the bend, but you know which way it goes. And this thing is getting pushed towards 0 as it moves towards infinity. From here, all you're going to do is something very simple that you learned in Algebra 1 is just take an input-output chart and take really easy values. Because what I want to do is I want to think about this function up here, and I want to think about really easy x's for me to use. So I'm going to take, for example, I'm going to use x is 0. So if x is 0, then just, I'm going to write this again. I have 4 times 1/2. Remember that x goes here, but you said that x is 0, so x is 0. Something really important to remember, that any number other than 0 raised to the 0 power is 1. So I'm like, this thing is not 0, but it's raised to the 0 power. Therefore, its total value is 1. So I evaluate this exponent first, and I have 4 times 1. Well, 4 times 1 is just 4. Look at this. Free. I got the point 0, 4. I'm going to do the same. Most professors or instructors want at least 2 points. So let's just get 2. It's easy for me to evaluate x as 1. That would give us, just going to write the equation again, 4 times 1/2. And it says to the x power, but we said x is 1. So I'm going to raise that to the first power. And 1/2 to the first power is 1/2. Well, what's 4 times 1/2? So I would take 4 times 1/2. 4 is the same as 4 over 1, is 4 over 2, which is just 2. Do you see how we're getting ordered pair solutions out of this? So this is the point 1, 2. And I had to stop for a second, like, oh my gosh, did I do that wrong? But no, it's going down. It went from 4, and as I move this way, when we were at x is 0, we had a height of 4, but when we went to the right and had x is 1, the height went down to 2. So it's doing what it's supposed to do. So here's our function, and that's how I would graph it. All right? All right, you guys. Hey, thanks for watching. I really appreciate it. If you have any questions or comments, please let me know. And if you haven't already subscribed, please subscribe. Thanks.